Alright, so in the previous video or maybe in the previous lesson, we learned already how to actually select a random sample by using the random number table. Okay, so from this video onwards, we are going to involve more the concept more on calculation. Okay, where we are going to calculate the probability for all the sampling. All right, so we call the whole thing as the whole subtopic as a sampling distribution. Okay, so first of all, sampling distribution means what is the shape of the sample that we have. Okay, and then in our A-level syllabus, the topic that we included in the syllabus is the sample mean, the sampling distribution or sample mean. All right, so the sample mean here is a keyword to actually hint you that the particular question is actually come from this part, the sample mean. Okay, and then you need to know also what is the mean of sample mean. It is equals to mu. And then what is the variance of sample mean? It is equals to standard variance divided by n. Okay, so again, when you're having E bracket sample mean means this one, right? The symbol. Okay, so the sample mean here means that the EX here means that it is actually the mean for sample mean. Okay, last time when we learned EX, right? So when we learn EX, this is actually mean for population or mean for X. So all the X that we learned before are population. All right, so this is actually the mean for population. And then if you look at this one, this will be the mean for sample mean. Okay, so the same thing happened here. All right, so if let's say you're having variance bracket sample mean, then it is actually the variance of sample mean. Okay, so last time when we learned variance X, this one means that it is actually the variance of population. Okay, so if let's say you see the formula for mean for the sample mean, right? The value itself is actually the population mean. Mu is population mean. Okay, and then the variance of sample mean, it is actually the population variance. This is population variance divided by sample size. So all this we'll discuss it later in detail, and we also know how to apply it. We'll learn how to apply it also. Okay, then after that, you need to also understand that the sample mean in our syllabus, right? We only learn one distribution only. That is belongs to the normal distribution. Okay, and after that, you also need to learn what is the central limit theorem. Okay, so central limit theorem, usually when we write it out, it is something like a theory or maybe a rules that you can apply. Okay, and then this central limit theorem we call it as CLT. Short form is CLT. Okay, so this is the learning outcome that you should know after we learn this whole part here. Okay, so let's start with the procedure of having the sample mean distribution. Okay, so this part now, for this particular part, how you gather all the sample mean and get the distribution is not really important, but it is just to show you all right, how we actually get all this, okay, from a population. Okay, so let us start. First of all, they take a random sample of n size from n observation from the population. So you see, from this is a population, I assume. Then I select a few values and form a sample. So I maybe name it as sample number 1. So after I get this particular first sample, right, I will try to calculate the mean of the sample here. So we call this as sample mean. Okay, and then the n here, your sample got size n, right? So this n we call as sample size. Okay, so by only forming one sample, it is not enough. If let's say you want the value to be very, very accurate, then you have to repeat the procedure until you have taken all possible sample size of n, calculating the mean of each sample. So you have to get the sample, all the possible sample that you can get from a population. Okay, if let's say you want it to be very, very accurate, so you have to try, okay, to get all the possible sample from the population, and then for every single sample that you get, you try to calculate the mean. So when you try to calculate the mean, right, so you have mean of sample 1, mean of sample 2, and so on. And after that, I try to collect all the mean together, okay, to make it of sample mean. So the mean of sample mean, I write as E, then sample mean, bracket sample mean, or we will call it as expected value of sample mean. And then after that, you can gather all the sample mean here. Also, you have a list of value here, right? You can also use it to calculate the standard deviation, okay, of sample mean, or they can write like this. All right, if not, then you just write as variance of sample mean. So the variance of sample mean will be variance, sorry. So the variance of sample mean will be VAR, okay, and then sample mean. Okay, so this procedure is general. So what you need to do is like you just need to roughly know about it. Okay, no need to go and memorize. Okay, no need to go and understand in very detailed. Okay, then let's have a look for part number 2. Okay, so when you group all the sample mean together, right? Okay, when you calculate the mean of the sample mean, when you calculate the variance of the sample mean, generally all the analysis from there you can actually try to get a pattern, okay, for the sample mean. So the pattern or the shape we call as the distribution of the sample mean. So again, I told you sample mean is one of the important keyword for this part. Okay, in the question itself, you have to look at this keyword, then only you know that, okay, this question belongs to sample mean. Or sometimes some other important keywords, usually they will look like this. There are some keywords here also. Like in the question, they tell you find the probability that mean length is less than 5. Or maybe ask you to find the probability that the mean time is less than 10 minutes. Or maybe the mean height, okay, or mean weight. Okay, so all these are actually the keyword that to hint you are having a sample mean question. Okay, so all these are the keywords. So I have to detect the keyword in your question. All right, okay, so try to detect it before you answer the question. Okay, so now we want to know how to get the value, okay, for sample mean of the sample mean, and also variance of the sample mean. So if let's say you are having EX is equals to mu, variance X is equals to sigma squared. Okay, so from now onwards, you need to know that EX, the mu here, we are assuming it as population mean. All the X are population mean. So for the population mean, we will use the mu to represent it. And then for this one, we will call it as population variance. So this is population variance. Okay, so let's say when you try to form the sample with an independent observation, then the sample mean here is x1 plus x2 plus until xn divided by n, correct? Then what is the important result? Okay, so here before I show you the important result, okay, so let's say there are some proving part that you can cover faster quickly. All right, so now if let's say they want you to calculate the mean of sample mean. So how to do it? Okay, so this is mean, expected value of sample mean. Okay, so you know that E x bar is actually E. What is the formula for x bar? It is x1 population, the element of population number 1, then the second element of the population plus x2 plus x3 until xn, then divided by n. Correct or not? So this is the mean for the sample mean, formula for the sample mean. Correct? Okay. And then in chapter 2, do you still remember when you are having E something like E2x, E3x, you can pull out the constant, right? Okay, so here n is a constant. The sample size is a constant. So the n here you can take it out. Okay, then for the E, you are having EX1, okay, plus EX2 plus EX3 until EXN. Okay, so all the EX1, EX2, EX3 means the population mean. Okay, so EX1, that means the population mean, which is mu. EX2, it is also the mu. ex3 is also the mu until exn, which is also the mu. So if you try to figure it out in detail, there are how many times of mu here? You're having n times of mu here. Okay, so when you're having n times of mu here, when you want to simplify it, will become 1 over n. That means n times of mu means n multiplied with mu. Okay, so from here, you can see that cancel off the n, and eventually the answer that you get is a mu only. So this is our very first important result. You should know that the mean of the sample mean is actually equals to the population mean. So this is the first result that you need to remember, and you will apply it very frequently in the calculation question. Okay, so always remember the mean of the sample mean is actually equals to the population mean. Okay, so please try to remember that. Okay, all right. Then now, how about the variance? So again, to get the variance of the sample mean, you still need to apply the chapter 2 concept. Hopefully you still remember. Okay, so to get the variance of the sample mean, okay, so what's the formula for the sample mean? It is actually variance, and then we are having x1 plus x2 until xn, then divided by n. Okay, so now you want to pull out the constant from variance. When you want to pull out the constant from variance, what you need to do is you need to actually try to square the number. So when I want to pull out the n, 1 over n, I need to square the 1 over n. And after that, I'm having variance. Okay, so when I write it out, it will become x1 plus variance x2 plus variance x3 until variance xn. Okay, so when I square this one, I will have 1 over n squared. Okay, so what's the population variance here? So the population variance will be sigma square plus this one is also the population variance sigma square also. So you just add them together until sigma square here. So again, how many times of sigma square you have? So again, you have n times of sigma square here, n times. Therefore, when you want to further simplify it, it will become 1 over n squared multiplied with n sigma squared. Then you will see that n and this square, the n, one of the n can be cancelled off. Eventually, what do you get here is you are having sigma square divided by n. So this is the second important formula that you need to know, which means to calculate the variance of the sample mean, the formula is you take the population's variance. This is the population variance, right? So population variance divided by sample size. So this is the important information also that you need to know. You will also use it very frequently in the calculation question. Okay, so summary for this part is what? Again, the mean of the sample mean is equal to the population mean. The variance of the sample mean is equal to population variance divided by n. Okay, so how you know that is population variance divided by n? So again, you can see the proving from this part. So this concept actually you learned it before in your chapter 2, right? Okay, so you apply the same concept and you will see that it is proof that the variance of the sample mean is equal to population variance divided by n. All right, therefore, if you look at the note in our notes, so I actually put in this as an important box or important result in the box, okay? So what is this? So you can see that the mean of the sample mean is equals to population mean. The variance, okay, of the sample mean is equals to population variance divided by n. And the proving part, I also show it here. Hopefully you will still remember. Okay, all right, so this is how we get the result. So these two result is super important because you need to use it to do the calculation later. Okay, all right. And then after that, there are something extra that you need to know. Okay, because our variance of the sample mean, right? The variance of the sample mean is equals to population variance divided by n. Therefore, if you want to change it become standard deviation of sample mean, it will become sigma over square root n. Correct or not? Okay, by using the common sense, you take the square root, right, for the variance to get standard deviation. Okay, so this sigma over square root n, what is the value here? Okay, so there's a special name. All right, although we call it as standard deviation of sample mean, but actually we also call it as standard error of the mean. Okay, so this is the standard error of the mean. Some question they will use this word lah, so therefore I actually introduce it in the note here, so that in the future if you see the word standard error, at least you know that the standard error of the mean means that it is actually the standard deviation of sample mean. It is just another special name for it. Okay, but if I'm not mistaken, there are some exercises or some book, they use this word, and then actually students don't really know what is the meaning of the standard error. All right, so the standard error is actually this one, sigma over square root n. Okay, all right, so this is what we have. And then this one, they say that because your population sigma, the population standard deviation of variance are divided by square root n of n, then the standard deviation of sample mean is smaller than the standard deviation of population. It's like that because when you take something divided by n, right? Okay, like population variance divided by n, you can see that the value that you get definitely is smaller one. All right, so that means the sample, the standard deviation or maybe the variance of sample mean is smaller than the population one, which is quite true because when you take the sample out, right? Okay, the sample is usually smaller than the population. So the spreadness will be also smaller. Or we will say that the sample means are much more clustered around mean than the population value. So this is something extra to let you know only. So you just need to know that population is a bigger group, but sample is a smaller group that you take it out from the population. All right, and then you need to know what is the formula for variance of sample mean, what is the formula for mean of the sample mean. Okay, so this is the introduction part about the sampling distribution. Okay, so again, in short, right, for this whole video, the most important thing is actually these two formulas. Okay, so if you don't understand the whole process at all, just try to remember these two formulas because it will be super important, all right, for you to do any calculation later. Okay, so we will stop here for this video, and then for the next video, I'm going to go into the calculation part. All right, to cover this with the distribution of sample mean when X is normally distributed.